So hello everyone, am I audible? Let me just check from my phone. So hello everyone, am I audible? Let me just check from my phone. So hello everyone, am I audible? So just let us wait for 2 to 3 minutes and then we'll be starting with the stream. So yeah, everything is running fine. We can just start with the problems. Generally we take 4 problems, one easy, two medium and one hard, but in this stream we'll be choosing 5 problems. So because tomorrow is Saturday, so we can extend this stream up till like 4 to 5 hours if possible. So what I have planned, I have taken 5 problems and we will discuss each of them in very detail, and the questions will be like one easy, one hard and three medium problems. Majority will be based on like recursion only, recursion backtracking thing, and the hard one will be I have taken for today, trapping rainwater. So yeah, this is the easy problem for now, so we can just start with it. So let me just check from my phone, and just after few seconds we will just start with this particular problem. Recursion only, recursion backtracking thing, and the hard one will be I have taken for today, trapping rainwater. So yeah, everything is running fine, so we can just start with this particular question. So this is the first easy question. After that we'll be solving three mediums, and in the end we'll be just solving one hard problem. And after each and every question we'll be discussing if you have any doubts in the chat section. So yeah, we can just start with this particular problem. So the problem name is longest common prefix. So we need to write a function to find the longest common prefix string amongst an array of strings. So what the question is saying that you have been provided with array of strings, and among that array of strings you need to compare each and every strings and find the longest common prefix among all of those strings inside the array of strings, which is possible. And if there is no common prefix, so we need to return an empty string. So let us see with the help of this first example. The input is given to us as flower, flow and flight, and you can see the output is FL. If we see the constraints, the string length can be as max as 200, and each and every string, like the array itself can have a length of 200, and inside that array each particular individual string can also have at max 200 length. So this is what the problem is saying. So let us see this first example and try to analyze what is this question actually. How can we derive some solution out of it in a most better solution way, rather than just a brute force manner, because in easy problems brute force also works. That is completely fine, but we will see better approaches as well. So we'll be taking this particular example where strings are given as flower, flow and flight. So yeah, let me just write this particular example here. Yeah. strs is given as, let me just write it. It is flower. Then what was that? Flow and then flight. And the output is given to us as FL. So this is the output. So first of all, let us see how we can get this particular output. So if we write this string like this, so first is flower, so FLOWER. The second one is flow, so FLOW, and the third one is flight, FLIGHT. So you can see here the first letter F is common in all of the three strings. So we can say that till now our longest common prefix consists of F only. Then we check the other character, it is L, and L. So we can say that okay, till now F and L is the longest common prefix that we can find in all the three strings. Then we come across the third character. So you can see here it is O, here it is O, and here it is I. So in two of them it is matching, but in the last one you can see here it is I. So we can't extend our prefix. So at max we can get the longest common prefix to as FL. So that's why you can see the output given to us is also FL. So this is what the question actually means. So how we can solve this particular problem? So the first approach can be the brute force approach. So let me just show you. I'll not write the code for the brute force approach. I'll just show you the brute force approach, and after that we'll be discussing and coding the better approaches. So the brute force approach will be, let me just take it here. Yes. So in the brute force approach, if we see FLOWER is there, then FLOW is there, and FLIGHT flight is there. So the brute force approach can be like compare each and every like position in all the three strings. So first of all, what I'm saying, so let us say if our current index is 0, so we will check zeroth index in all the three strings, like whether we are getting the common character or not. So let's say we first iterate it to this string, so we check at let's say whatever this is, let's say this is S1, this is S2, and this is S3. So let's say we first check the zeroth index of S1, so it is F. So now we check whether in S2 and S3 the zeroth character is F or not. If it is, then we can extend our prefix. Otherwise, if it is not, we can just break from here, and whatever the longest common prefix that we have till now, we can return that. So we come across S2. So at S2 the zeroth character is F. So again, yes, it is matching with the previous one, so we can say that okay, till now it is working fine. So we now came across S3. So S3's zero character is also F. So for zeroth position, all the three strings have a common character, that is F. So we can say that the longest common prefix that we have till now is F. Now we move across I equal to 1. So now we again check in each and every string at first index whether all the characters are same at this particular index or not. So we came across S1. So we check S1 of I, like S1 of 1, we will check S1 of 1, we will check S2 of 1, and we will check S3 of 1. So if all the three are same, that means we can say that okay, we can extend our prefix with S1 of 1 or S2 of 1 or S3 of 1, because all three are same. So we check S1 of 1. So S1 of 1 is L. So okay, that means now S2 of 1 and S3 of 1 must be equal to L. So now we check S2 of 1. So S2 of 1 is again L. So now we check S3 of 1. So S3 of 1 is again L. So all the three characters at this position is again same. So that means we can extend our prefix again. So till now our prefix will become FL. Now it is done till now. Now we will check for I equal to 2. So I equal to 2. Now again S1 of 2, S2 of 2 and S3 of 2. All three must be same, then only we can extend that particular character in our longest common prefix. Otherwise we need to break from here, because prefix must be continuous, right? So we check first S1 of 2. So S1 of 2 is O. That means S2 of 2 and S3 of 2 now again must have O only as their second character, like based on indexing. So now we check S2 of 2. So S2 of 2 is again O. So we can say that okay, till now it is working fine. So now we check S3 of 2. So S3 of 2 is now I. So in S1 of 1 we got O. In S2 of 2 we got O. But in S3 of 2 we got what? We got I. So that means this is not matching, and since all the characters at the same index is not same in three of the strings, that means we cannot extend our prefix till now. So now we need to break from here, and whatever prefix that we built till now will be the longest common prefix. So you can see we build FL, so we'll be returning this as our output, and if you know, the output was also FL. So this is the brute force manner. So now we will see how we can approach it in a better way. Because why this approach is not good? Because we need to do repetitive tasks. We need to check each and every index in all the three strings. Again we need to do same thing again and again and again. So instead, if we can find some observation and like do get something from that observation, then we'll be good to go. So let us see the better approach for this. So let me just move it down. Yes. So now will be the better approach. So in better approach we will have some observation. So let's say the strings are given in some sorted order. This is the observation that you will get when you try a few examples after the dry run. So this is the observation that I found. So if the strings are given in sorted order, let's say this is the strings array. Let's say there is some string. So we sorted them in ascending order, lexicographically basically means, because these are strings, so sorting means sorting in terms of lexicographical order. So let's say we sorted that, and let's assume whatever the strings here are, we just need to understand the thought process here. So let's say this is the string which is the smallest in lexicographical order, and this is the string which is largest in lexicographical order. So now just tell me one thing: if this string, this particular first string, and let's say some string here, if these two strings are having their first three characters same, so do we even need to check these three strings, that whether these three strings are having their first three characters same or not? No, we do not need to check for them, because these are sorted in lexicographical order. So if this particular string is having FLO, and this also has having the first three characters as FLO, then obviously these three strings will also have their first three characters as F, L and O. This is for sure, because we have sorted in lexicographical order. So that's why this is the main observation. So why this is important? Because we have seen in the brute force approach, we are trying and processing for each and every string, right? So we need to remove that thing. We need to do some smart work in order to reduce the time complexity. So side by side, if you have any doubts, so you can also write it in the chat section, chats as well. So that's why we sorted it, and now we do not need to compare with each and every string whether each and every index is same or not. We just need to compare two strings. Now what will be the two strings that we need to compare? So again take the same example. So let me just move it down a little bit. Yes. So let's say here also we have some strings. These are sorted in lexicographical order. So just tell me what will be the worst case. What are the two strings that we need to compare in the worst possible scenario? We can take this string and we can take this string. Since these are sorted in lexicographical order, the most different or the most difference between the characters will be in these two strings only, because this is the smallest in lexicographical order and this is the largest in lexicographical order. So now within these two strings we just need to find the common characters, like prefix wise we need to find the common prefix. Now if there is the common prefix, let's say x, y, z, among these two strings, then obviously these strings in middle will also have the common prefix as xyz, because these are sorted in lexicographical order. So this is the main observation and this is how we'll be proceeding for this particular problem. So let us take that same example of flower, flow and flight and see how we can solve this particular problem. So let us take the same array, that was flower, flow and what was that, flight. So now we sort them in lexicographical order. So after sorting it will become something like this. It will be first flight, then it will come flow and then it will come flower. So these are sorted in lexicographical order. Sorted order. So now what we need to do, we just need to find the common prefix between the first and the last string, and whatever the common prefix will be, that will obviously be in the that will be also in the middle strings as well, because we have already sorted in the lexicographical order. So that is what the entire logic is in this particular problem. So let us find the common prefix in this particular case. So we take flight, FLIGHT, and we take flower, FLOWER. So let me just side by side open in my phone if something has come. What's cooking here? Yeah, Joga Banito, we are just solving today's problems. So we'll be solving 5 problems today. 1 easy, 1 hard and 3 mediums. So till now we are solving the first problem, that is longest common prefix, and yeah, we are just discussing the better approach. We have already discussed the brute force approach. So let me just check my stream as well via my account. So yeah, everything is fine till now. So yeah, if you have any doubts till now, you can write it in the chat section. We will be just now solving with the better approach for this particular example. So these are the two strings that we will be comparing, flight and flower. So we will, for these two strings we just need to iterate on each and every index. Now we don't need to do for each and every string. Previously we were checking I equal to 0, I equal to 1, I equal to 2 for each and every string that was possible in our array. But now in this case we'll be checking for only 2 strings for each and every character. So this reduces our time complexity by O of n, where n is the length of the array. So now let's say we are first checking for I equal to 0. So let's say this is string s1 and let's say this is string s2. So first we'll be checking s1 of 0 and we'll be checking s2 of 0, and let's say this is our answer. Initially everything will be empty. So yeah, let's say s1 of 0 is f and s2 of 0 is also f. So till now, yes, in both the strings f is matching, so we can say that okay, the longest common prefix that we have till now is f. So now we can move forward with the I equal to 1. So now we'll be checking for I equal to 1. So in I equal to 1, we'll be checking s1 of 1 and s2 of 1. So when we come across s1 of 1, we got L. So okay, now s2 of 1 should also contain L. So we see s2 of 1. So yes, s2 of 1 is also containing L. That means we can extend our prefix with L also. So till now our longest common prefix will be f and L. So now we need to come to I equal to 2. So now in this case we need to check s1 of 2 and s2 of 2. So in this case also s1 of 2 and s2 of 2 both must be same. So s1 of 1 is I and s2 of 2 is O. So these are not equal. That means now we cannot extend our longest common prefix. So whatever prefix that we have till now should be the longest common prefix. So you see our answer is FL. And if you have seen the output of the example test case, the answer was FL only, and when we saw with the brute force approach, our answer was FL only. So yeah, with this logic, with this particular logic, we can say that okay, the longest common prefix that we will have is FL. So let us just write the pseudo code now, and then we'll be actually coding it in the LeetCode. So yeah, till now if you have any doubt, you can ask it in the chat. We'll be waiting for 2 to 3 minutes, and then we'll be writing the pseudo code in the whiteboard, and then we'll be writing the actual code in the code editor. I think someone has written something in the chat few seconds ago, so if he or she has something to ask, they can ask. So yeah, now we can just write the pseudo code. So first of all, what we need to do, we need to sort the entire strings array. So what we will do, we'll sort strs dot begin and strs dot end. So now we'll be having the entire strings array in the lexicographical order. So now if we have the strings in the lexicographical order, we just need to compare two strings, the first string and the last string. So let's say we take the first string as string first, sorry for this, first, and that will be nothing but strs, that is now the sorted order, strs of 0. And we will take the string last, which will be nothing but strs of n minus 1. Obviously n is the length of the strings array basically. So strs dot size, so integer n. So yeah, now we have the first string and now we have the last string. Now we just need to compare each and every character for this, or for each and every index. So now what we can do, we can run a loop. So for I equal to 0 up till I less than what, the length of first or last, whichever is the minimum length. So we will take minimum of first dot size and last dot size, whatever, like I'm just writing last dot s and first dot s because there is less space. And yeah, we'll be doing I plus plus. So now we are comparing each and every character for string first and string last for each and every index. So now what we will be comparing actually, so let me just take it down. Yes, so initially we have seen we were comparing s1 of 0, then we were comparing s2 of 0. So for 0th index we compared, then we were comparing s1 of 1 and s2 of 1. So you see, these are the indexes. So we have looped for the indexes, and we just now need to check whether the both of the characters for first and last string are same or not. So we will check a condition. If first of I is equal to, or rather we can say if not equal to, we can check opposite condition as well. If first of I is not equal to last of I, that means whatever answer that we have till now must be returned. So we need to break from this particular scenario. So we will just break. Otherwise, whatever longest common prefix that we have till now, we need to add that, because both the strings have the same character. So both the strings have same character. That means we just need to add the character to our maximum prefix that we have till now. So let's say the maximum common prefix we are storing it in answer variable, string answer. So let's say we declare one string answer also, which will be initially empty, because if no common prefix will be there, we need to return an empty string. So that's why. So we will just add answer plus equal to first of I. So yes, if the character matches, this condition will be fulfilled. If the character does not matches, we will just break out of this particular for loop. And if we break out of this particular for loop, that means we got our largest or the longest common prefix. So we need to return that. And what is that? Answer. So we will be returning answer. So yeah, this is how we'll be solving this particular problem. So we can just write this code in the LeetCode code editor, and after this problem we can just discuss if somebody is having some doubts, or we can just move on to the next problem, whatever you guys say. So let me just write it. Yes, so we have integer n as what? String dot size. So strs dot size. Now what we need to do? First we need to sort everything in the lexicographical order. Then only we will be able to get the first and the last, which is the worst possible case for the strings to be compared. In between all of them, they will be already following the common prefix, because if the smallest and the largest string having some common character, that means obviously in between those will also have the same prefix characters as well. So this is the logic that we are following. So we'll be sorting strs dot begin comma strs dot end. So now we have sorted this. Now what we need to do? So sorry, there is a typing mistake. Strs dot, yeah. So after this, what we need to do? We need to take the first string. So string first is nothing but strs of 0, and string last is what? Before that we need to, yeah, we have already taken n as the integer. So string last is nothing but strs of n minus 1. So strs of n minus 1. Yes, now we just need to check each and every character for both of these strings, whether these characters are matching or not. So we can take one string answer, which will be initially empty, which will be storing the longest common prefix, and this will get returned in the end. So whatever common prefix that we get, will be just returning that. But before that, we need to take what is actually the longest common prefix. So we'll be running a loop for I equal to 0 up till I is less than what? Because first string and the last string may differ on length. So whatever has the minimum length, only till then only we'll be able to iterate, right? So we'll take minimum of first dot size comma last dot size, and yes, we can do I plus plus. Now what we need to compare? Whether the ith character is matching in both strings or not. If the ith character is matching, then we can just add that particular character to our longest common prefix. Otherwise we can just break out from this for loop, because now we won't be able to extend our prefix that we have till now. So if those characters are not matching, if first of I is not equal to last of I, then what we can do? We can just break. Otherwise we can just extend our longest common prefix by first of I or last of I, doesn't matter, because both are containing the same character. And if we break at any position, we will be just returning our longest common prefix that we have till now. So let us see if this runs on the example test cases or not. So yeah, it runs fine. So let us submit whether it gets submitted or not. So yeah, it got submitted. So if you have any doubts till now, you can just ask, and then we'll be moving to the next problem. So let me just check the stream as well. So yeah, if you have any doubts, you can just ask it. Let me check on the stream as well. So yeah, there is something in the live chat. So yeah, I don't have any doubt so far. Just don't understand your code. I'll convert this code later when the stream ends. Convert this code like what? In some other language are you talking about? Or if you didn't understand this particular problem code, then we can discuss it again. So आज का POTD explain कर दो. So Dhruv, we have already discussed in the like previous live streams, like we'll be taking the, what you can say, the people have already told the problems that I need to take in the today's live stream. Like someone has told for top k element, someone has told for sub array kind of thing, someone has told for recursion backtracking. So for today I have already selected question, but if you want to explain me today's PUTD, maybe I'll just take it in tomorrow's live stream, because today I have already taken the 5 questions, so I'll be just explaining those. JavaScript का आदत है थोड़ा. Okay, yeah, no problem. If yeah, but I would prefer you to do it in either C++ or Java rather than JavaScript. Okay, top K. Yes, the next question will be of top K only. Aryan Singh, I did the same question today but differently. So can you tell Aryan Singh what different did you did? Okay, log of n square or just O of n square are you talking about? There was the brute force approach and the better approach, and there was, I think, optimal approach as well, O of m cross n. But yeah, that we don't need to discuss right now, because if we discuss so many approaches, then we'll not be able to end this live stream by solving the 5 problems, because just for the easy problem we have discussed so many things, like you can see. O of n square, okay, yeah, O of n square, that was not actually O of n square, that was actually O of n cross m, where n is the length of the array and like m was the like maximum length of the string, or sorry, the minimum length of the string that we could iterate, something like that. So we'll be taking the next problem of like top k as discussed. If you have anything, you can just write it in the chat. We'll be just starting this problem after like few minutes. Sure, I'll try C++ or Java. Yeah, you can try that. So top k frequent words we have already discussed in like 2 days ago. So I have thought to take top k frequent elements for this particular live stream. Let me just reset this. Yeah, we'll be solving this particular problem. In this we do not need to even discuss the like brute force approach. It is pretty much simple, I think. We can just discuss the original or the best approach, you can say, and we'll be good to go. I'll be showing you the drawing explanation as well, how the things actually work when we solve this problem, as we have done for the previous problem, the prefix one. So we have seen step by step how everything works. We have written the pseudocode, not actually the pseudocode, we have actually written the entire code. Yeah, so similarly we will do for this particular problem as well. So we can just select all. So if you don't have any doubts, we can just start with the top k frequent elements question. So yeah, we can just start now. So the next problem is the top k frequent elements. So let us read the problem's statement first. It is pretty much straightforward. So given an integer array nums and an integer k, we need to return the k most frequent elements, and we can return answer in any order. So first of all, order doesn't matter in this particular case, and we just need to return the top k frequent elements. So what does the top k frequent element means? So let us understand with the help of first example. So we need to here return top two frequent elements. So frequent elements means based on frequency. So let's say in this case 1 is occurring 3 number of time, 2 is occurring 2 number of time, and 3 is occurring 1 number of time. So in this case you can see the most frequent element is what? 1, because it is having 3 frequency of 3. What is the second most frequent element? 2, because it is having the frequency of 2. But here we need to return both k equal to 2. That means we need to return top 2 frequent element. So we will be returning 1 with the highest frequency, and we will be returning 2 with the second highest frequency. So this is what the question means. So let us draw this particular case, or we can see second example if it is given good, better. We can take this third example. It is 1 2 1 2 1 2, and yeah, we can just take this particular example. So nums is given 1 comma 2 comma 1 comma 2 comma 1 comma 2, and I think it was 3 1 3 2. If I am not wrong, it was this only. 3 1 3 2 1 2 1 2 1 2, yes, and k is given to us as 2. So again here also we need to find top 2 frequent elements. So if we just draw a kind of frequency map kind of thing, what we can say, 1 here is occurring how many number of time? 1 is occurring 1 2 3 4 number of time. So we can say okay, 1 is occurring 4 number of time. Now let's say how many times 2 is occurring. So we can say okay, 1 2 3 and 4. So we can say okay, 2 is occurring 4 number of time. So what is the remaining number? Now we have 3. So we can see 3 is occurring 2 number of time. So we can say okay, 3 is occurring 2 number of time. Since we need to return the top 2 frequent elements, so we will be returning 1 and 2. So our output will be nothing but 1 comma 2. So this is based on like frequency. Maximum frequency should be coming first. It is a kind of priority thing. So someone has asked, heap and pair से हो जाएगा ये तो. Yes, exactly, we'll be using max heap, and inside that max heap we'll be storing pair of int comma int, in which the first integer will be denoting the frequency and the second integer will be denoting that number. So yes, correct, Dhruv. We'll be solving with the help of this approach only. So here you can see frequency is important. On the basis of priority of frequency, we need to sort everything. So we'll be using priority queues. So we can directly discuss the priority queue approach. So what we can write? We can name this approach as priority queue plus what's hash map. So yes, now what will be the approach? So we need to first store frequencies, obviously, then only we'll be able to store frequencies inside priority queue. So first we will be using hash map. In that hash map we'll be storing the frequencies. So if we just draw that entire array again, the array was 1 2 1 2 1 2 3 1 3 2. So yes, so first we'll be using map. So let's say this is our map. So again we'll be drawing everything. So 1 doesn't exist inside our map till now, so we can just put its key and mark its frequency as 1. Now we have 2 came, so we are just iterating on the entire nums array. Now the number came to us is 2. So 2 doesn't exist inside our map, so the 2 key will be created and its frequency will be set to 1. Now again we came across 1, so 1 key already exists in the map, so we'll just update its frequency by 1. So now 1's frequency is 2. Now we come across 2, so 2 already exists, so we'll just increase its frequency by 1. Now again 1 came, 1 already exists, so we'll increase its frequency by 1. Again 2 came, so we'll just increase its frequency by 1. Now 3 came, so 3 doesn't exist inside our map, so we'll just insert its key and make its frequency to be 1. Then again 1 came, so we'll just update its frequency by 1, so it will become 4. Again 3 came, so we'll just update its frequency by 2, and in the end 2 came, so we'll again update its frequency by 1, so it will become 4. So we have iterated the entire array, and this is what our map looks like. 1 is coming 4 number of time, 2 is coming 4 number of time, and 3 is also coming 3 is coming 2 number of time. So this is the frequency map we have created, but now we need to prioritize top k elements on the basis of frequency. So what we can use a max heap. So in that max heap, what we will be storing? We'll be storing two things. So let's say this is one pair of our max heap, so it will store two things. First it will be storing frequency, and second it will be storing the number. So let's say this is the case, so 3 is the number, 2 is the frequency, so it will be something like this, 2 comma 3. That means 3 is occurring 2 number of time. So why we have taken frequency? Because in heaps, everything, if we are storing a pair, everything's sort on the basis of first number. If first number is same, then it will sort on the basis of second number. So in max heap, it will return the top element as the like the element having the most frequency will be on the top of our priority queue, and we will just extract the top k element from our priority queue, and we will be returning that. So let us see again how we'll be storing this inside priority queue. So let's say this is our priority queue. So first of all, we'll be iterating from the map. So you can see in the map the first number is 1 with frequency 4. So what we can do, we can insert frequency 4, and initially it will be not on top, but yeah, I know like what will be the order, so I'm just drawing the resultant priority queue. But inside it has a heapify function, so it just call, and if new number needs to change the ordering, it just changes internally by log n operation and all of that. So we are not going to discuss in that much detail. So yeah, its frequency is 4 and that number is 1. So the next number that we came inside the map is 2. So 2's frequency is 4 and the number is 2. Then the next number that came inside our map is 3. So its frequency is 2 and the number is 3. So this is our priority queue. So this is our priority queue. Priority on the basis of frequency, and if the same frequencies there, so we'll be taking on the basis of number. So you can say that okay, 2 will be on the top and all of that. That doesn't matter because we do need to take care of the frequencies here only. So now we just need to extract the top k elements. So our top k elements will be what? These two. Since k is 2, k is here 2, so what we can do, we can return this number 1 and number 2. So we are just taking out the elements. So taking out the elements mean we'll be taking out the pairs. So here it will be frequency and here it will be number. So we have taken out the number, here it will be frequency and number. So in our resultant answer, what we will do, let's say this is the top element, so we can just take top dot second, because we just need to take the number, not the frequency. So this is how we'll be doing. We'll not equate it, we'll just push back into our answer. This is just I have written for some example scenario. We'll be actually doing something like this: answer dot pushback of, let's say we have extracted the pair and that pair is named as p, so we'll write p dot second. So in the end we'll be just returning this particular answer. So let us write the code here, or let us write the pseudocode here, and then we'll be discussing the entire code in the code editor. So first of all, what we'll do, we'll declare an unordered map, because here order does not matter, we just need to take care of the frequency. So unordered map of integer comma integer. After that, let's say it is named as mp. Now we'll first iterate over the entire nums array. So I equal to 0 up till I is less than n. So I'm just writing in a basic pseudocode manner. So we'll just do something like this: mp of nums of I plus plus. So if the key doesn't exist, it will insert the key and increment its frequency, so its frequency will be 1, and if the key already exists, it will just increment by 1. So merge top की list वाला करना sir इसके बाद please. So Dhruv, like I have already selected the 5 questions, so maybe we can take in the next live stream if possible. So in the chat you can like write what questions you want me to do in the next live stream, because they were already piled up question from the previous 3 streams. Somebody has told for valid sudoku, so till now I have also not taken that valid sudoku thing. So in the next live stream maybe I'll take today's POTD, merge top k list, and the valid sudoku one. Or if you have some any other suggestions, like I can take those as well. And if the key already exists, then it will just increment its frequency by 1. So yeah, till now we have just taken care of the map thing, and after this map we need to do everything with the help of priority queue. So we'll declare a priority queue. So priority queue, in that we'll be taking pair. Now this priority queue will be actually max heap. So it was me, yeah, Aryan Singh. So the valid sudoku one was, yeah, so we'll take in the next live stream. Sorry I couldn't take today. Aman, I just want to reach 1850 and earn night, but all my friend do cheating. Okay, so taking in next section. By the way, you are safe to. No, Aman, I am not on Code Forces. I used to practice in my first year, but I have solved like few 500 problems there. Not in a very high difficulty range. Around 1200, 1300 I have practiced. Then I have moved to LeetCode. Regarding night, yeah, currently there is lot of cheating going on in the contest. I just stopped giving contests. I just after the contest and I solved it by myself, because yeah, there is no point I think nowadays in the contest. So forget about the rating. If you still want to gain, you'll be able to gain it easily. Night batch, you just need to like generally in the LeetCode nowadays the first 3 problems are solvable if you have like solved few hundred problems as well. If you have a good understanding of data structures, so you can just solve first 3 problems quickly without any errors. And if you do this for like 3 to 4 contests regularly, then you will be able to easily get the night badge. Like you just need to make sure that you rank between 3000 to 5000 in the next 4 to 5 contest, and you'll be good to go for the night badge. But the cheating thing is really, like, it is peaking with after this AI thing has came. We can't do anything for that. So priority queue will be taking integer comma integer, and let's say we name it PQ. So now we need to prioritize on the basis of frequency. So this is nothing but this is max heap only. So what we'll do, we'll just iterate for inside the map. So for auto IT of MP, what we'll do, we'll just insert it in our PQ dot insert. Insert what? We'll be inserting two things. First, the frequency it dot second, because frequency is the second element inside the map, and the number. So number is the first element. So it dot first, which is the actual key inside our map. So after doing this, we just need to like return the top k most frequent elements. So for the top k frequent elements, we can just run a while loop, while k minus minus, and while k minus minus will be taking the pair first out. So pair will be taking of int comma int, which will be nothing but, let's say, p. So p will be nothing but what you can say, pq dot top. If you do pq dot top, that means you have already processed that top element, so you need to now pop that also. So pq dot pop, and after that let's say we declared a vector of int answer. So we can just push answer dot push back. So I'm just writing pb push back what, p dot second, because the number is actually second, the first one is the frequency. We don't need to do anything with the frequency, we just need to take care with the number, and in the end we can just return that particular answer. So yeah, this is how we'll be doing. Yeah, my cousin is in Amazon SD2. He said in every resume we can't see whether they are actually have ranks or fixed. Yeah, that is actually true, but yeah, we can't do anything for that rather than just relying on luck. So yeah, we can just write the code for this particular thing now, and then we'll be moving on to the two backtracking problems. After this, we'll take like 10 to 15 minutes of break, so that if you have anything to ask, you can just ask in the chat section. So for now, we can just write the code. So let's say the nums is int n equal to nums dot size, and we'll be first creating the unordered map of, let's say, int comma int mp, and let's say we create priority queue also. Now only priority queue of it will be of pair of integer comma integer, which will be pq. So first of all, we just need to store each and every frequency. So it 0 up till n, we just need to do mp of nums of I plus plus. After that, so luck is really needed, sadly. Yeah, it is needed, but if you are doing hard work, luck will always be with you. That's how I think. So we just need to take frequency in the priority queue, and then the second element as the number. So what we can do, we can just iterate over the entire map. So auto it over mp, it will be what, pq dot insert it dot second comma it dot first. After that, we just need to take the top k elements. So while k minus minus, it will make sure that after k becomes 0, we just move out of this loop and doesn't take any further elements. So let's say we declare a vector answer, vector of int answer, which will be storing the top k frequent elements. So what we need to do, yeah, we will create a pair of int comma int, which will be, let's say, p, and it will be nothing but pq dot top, and we just need to pop out this element, the top element, because we will now process that element, so we will not be needing after that we'll be taking the next element. So answer will be pushback of what? The second element. The second element is what inside the priority queue? The number itself. So what was that? P dot second. So yeah, in the end we'll be just returning the answer. So let's see if it runs fine or not. So it gives error pq dot insert. Oh sorry, we don't insert here, that I have written in the pseudocode. We actually push inside the priority queue, not insert. So yeah, it runs fine. You can see 1212, and we can now just submit this particular thing, and let's see if gets submitted or not. So yeah, it got accepted. So yeah, this was the particular problem. So if you have anything to ask, you can just ask related to this problem or anything. We can just discuss for like, let's say 10 to 15 minutes, and then we'll be solving on to the next particular problem. Next problem. So next problem will be backtracking problem. I don't know what I have taken. It was combination some part 1 and part 2 will be solving, because in the very first live stream we have solved similar problems. So now we again take back to the backtracking thing again. So yeah, so today we'll be solving backtracking problem, and tomorrow also we'll be solving the backtracking problem that will be of like valid sudoku. So yeah, the next two problems will be combination sum 1 and combination sum 2. So take next problem. Okay, nice. Okay. So you can give me feedback whether like my explanation is like whether you are able to understand what I'm explaining or not. Anything like that. It will be really nice feedback for me as well. Thank you, Dhruv. Really means a lot. So stream is running fine, I think. Yes. So yeah, we can just start with the next problem. Then the next problem is combination sum part 1. So let us read the problem statement first. So given an array of distinct integers, so each and every integer will be distinct, nothing will be repeated. So best tutor, thank you Joga Banitu, means a lot, thank you. So each and every integer in the array will be unique, nothing will be repeated. So and you are also given one target integer which is target. So we need to return the list of all the unique combinations from this integer array candidates, where the chosen sum numbers that we have chosen, their sum will be equal to target. So let's say the target is given as 7 and we choose numbers as 2, 2 and 3, so their sum is nothing but 7. So that's how that's what the question is saying. So and we can answer, we can return the combination in any order. Now they have also given that the same number may be chosen from the candidates like unlimited number of times, any number of times. So let's say here even the 2 is present only one number of time, we can take 2 any number of times. So in the first output example you can see 2 we are taking 2 number of time. So this is what it means. Now two combinations are unique if the frequency of at least one of the chosen is different. Yeah, so even if the let's say some other combination would be like 2 2 2 3, so it will be unique because here the 2's frequency is different from the 2 2 3 1. So that is what it means. And then they have said that the test cases are generated such that the number of unique combinations that sum up to target is less than 150. Yeah, just the additional condition that we need to take care in the mind. Yeah, so what the question basically means that we are given the candidates and we need to choose numbers from the candidates, and we need to choose in such a way that we the sum of the chosen candidates must be equal to the target, and we can choose a particular candidate any number of time. So this is what the question is saying, and we can return the answer in any order. We don't need to care of anything, and we just need to take care that each and every combination is unique. So that is what it basically means. Yeah, so let us see this first example and try to understand what the question how the question will actually look, and then we'll be able to solve it with the how we'll be able to solve it with backtracking and all of that. We will be seeing that also. So yeah, the number is 2367. 2 3 6 7 and the target is also 7. So how we'll be able to solve this particular problem? Because the question is very straightforward. We just need to pick some elements, their sum will be equal to target, and we can choose a particular number any number of time. We can return answer in any order. We just need to make sure that the combination we choose is unique. That's all. The question is pretty much straightforward, but how will we solve it? So let us have a basic understanding how we can solve this. So when what we'll be iterating over the entire array of nums. So let's say we are at this particular element. So at this particular element we'll be having two choices. Either we can take this particular element into our account, or we cannot take this particular element into our account. So two choices, either take it or not take it. So if we take it, so our outputs first array would like one of the combination would look something till now like this if we take it. If we not take it, the array will still be empty. Now if we have taken this 2, so that means we can again take 2, or we can just move forward with the next index. I'll be not drawing the entire recursion tree, it will be very long, but I'll just give a basic hint what the logic will be following. So if we have taken 2, so next we have again choices. Either we can remain at the same element, or we can go to the next element. So let's say we remain at 2 only. So if we are at 2, we again have two choices. Either we can take 2 or we cannot take 2. So if we take 2, so our combination till now will become 2 2, and if we do not take 2, it will remain 2 only. Now if we move on to some other index, like the next index 2 3, like it is 3, the next element is 3. So we have again two choices. Either we can take 3 or we cannot take 3. So let's say if we take 3, so one of the combination will become something like this, 2 3. And if we do not take 3, it will be like 2 only. So I am not drawing the entire recursion tree, just giving you a basic idea how the logic will look, actually what the logic is actually in this particular question. Now when we are at 2 2, again we have choices, but side by side we need to also make sure what is our target and whether we actually made it equal to target or not, whether we exceed our target. So that means we need to prune that condition, because then it will be just keep on moving, right? So when we take 2, our target will now become what? Our target will become 5. When we take 2 comma 2, our target will now become what? Our target will now become, we need to subtract 4, so it will become 3. When we take 2 comma 3, our target will become what? Our target will become 2. So now when we are at this particular stage, we have two choices again, like whether we can be at the same index or we can be at the next index. So if we are at the same index, so let me just move it down a little bit. Yeah, so if we are at the same index, we will again choose, we will again have option, either we can choose 2 or we cannot choose 2. So let's say if we choose 2, so now our array would look some, or now our combination will look something like this: 2 2 2. So and now our target will become 1. Target will now become 1. But if we moved on to next index, the next index element will be 3. So again we have two choices, either we can take 3 or we do not take 3. So if we take 3, our combination will become something like this: 2 2 3. So our target will now become 0. Now if our target becomes 0, that means we found a particular combination, so we can just insert this particular combination into our resultant array. Now this will keep on going for each and every case. Let's say we like came across 2 2 2 2 2, all that, and now we further the recursion calls. Now the target is 1, so again we have choices, either we can take 2 or we can skip 2. But if we take 2, our target will become negative, so that means we cannot take 2, and if we cannot take 2, that means we need to move on to the next index. So if we move on to the next index, you see all the elements that are there: 3 6 and 7. Whatever element will be choosing, that will always make our target to negative, that will always make our target less than 0. So that means with first 3 elements as 2 2 2, we cannot make our combination equal to target, because target is 7, our sum till now is already 6, and there is no element with 1 inside our nums array. So that means we will somehow reach, our I pointer will somehow reach end of the array. So at that time we can check this condition, target 0 also. You can check it separately also, but this will be the base condition that will be fulfilled for each and every case. So we can say that when our I will reach the end of the array, when our I is reached end of the array, we will check whether our target is equal to 0. That means we have made, or we have found a particular combination. So if we have found a particular combination, we can just push that particular combination into our result. So result dot push back the combination that we found, and if it do not fulfills the target equal to 0 condition, we can simply return. So this is how we'll be following with the particular question. So what is happening here, we can just summarize that. This is also a concept in DP also, knapsack thing. This is not actually knapsack, this is actually backtracking, but the like fundamental thing what we are doing here, that we do in knapsack also. Knapsack is what? Either take it or not take it. 0 means not take, 1 means take it. So there is a problem called 0 1 knapsack. So here also what we are doing, at each and every step we are deciding whether to take 2, yes, or whether to not take 2, we do not take 2. So this is the same fundamental logic that is we are following here. So how we can do this, we can just write the pseudocode now, or we can just summarize this each and everything that we have done till now. So we'll be starting at each and every index, we'll be iterating over the nums array, we'll be just moving forward with each and every index. At each and every index we'll be having an option, either we can take that or not take that. If we take that, we will subtract that particular value from the target, and then we will move our recursion forward. There are two choices in moving the recursion forward. We can remain at the same element, or we can just move forward with the next element. If we move on to the next element, we'll be doing the same thing again, or if we be at the same element, then also we'll be doing the same thing again and again. We'll be doing this entire thing again and again until our I pointer reaches the end of the array. So when our I pointer reaches the end of the array, that means we have scanned the entire array. Then we will check in the end whether our target became 0 or not. So if our target becomes 0, that means we found that particular combination. If it does not become equal to 0, that means the combination that we found is invalid. So we just simply return from there, and if we found a valid combination, we will just store it into our answer. So this is the basic thing that we'll be doing. So let me just write the pseudocode for this. Let's say we have some main function, because here we'll be using backtracking thing. So let's say this is the main function that LeetCode has provided to us. So what we'll be taking a vector of int, you say. So my recursion is only weak part, due to that I suffer in trees too. Yeah, recursion is the fundamental thing in trees, dynamic programming, and some linked list problem as well. So yeah, recursion must be like very strong in order to move forward with the advanced topic as well, because in DP also we first write recursion and then we memoize it. So yeah, like this is the thing. Many people stuck at recursion because it is very hard to visualize. But one tip that I would suggest, that how I did, I used to spend like around 40 to 30 minutes 30 to 40 minutes in drawing the recursion tree. Like the recursion tree that I have drawn here, sorry, the recursion tree that I drawn here is not fully, but when I used to practice, I used to draw the entire recursion tree in order to fully understand. So maybe that thing will help you, so you can try out that also. Aman, in which year are you in? Okay, yeah, so we can take vector of int result. And let's say we will have a current combination as vector of int combination. Now we'll be just using recursion in order to find all the possible unique combinations. So what we'll be doing, we'll be calling a solve function, which will be taking our result, will be taking our combination, it will be taking our the nums, the current sum that we have, current sum, or let's say we can just keep a target only, and we can just do subtraction as well. So target, in the end, after this recursion call, whatever result that we get of all the combinations, we can just return that particular result. We'll try to see. Okay, so we can just write the solve function now. So solve function will be actually void, because in this we are not returning anything, we are just finding out all the possible combination. So it will have all the required parameters, and the first one will be the base case. If I reaches equal to n, then we'll check whether our target becomes 0 or not. So whether our target became equal to 0 or not. So if it became equal to 0, that means our current combination is valid. So we will just push it into our result vector, or result matrix, you can say. So result dot push back combination. Otherwise, if this condition is not fulfilled, we can just return, or even if the condition is valid, we need to return somehow anyway. So this will be the base condition. So on campus didn't got option. Okay, so if this was the base case, now what we need to do, we need to take either the same element, or we need to take move forward with the next element. So let's say if we take the next element, and when we will be able to take the next element, obviously if the current element is lesser than or equal to target. So we will be checking one condition. If our current element will be denoted by I. So we'll be taking that I parameter or the index parameter also. I have currently not taken in the pseudocode, but yeah, it is obvious we'll be taking that. So Mohit is here. Hello Mohit, how are you? So if candidate or nums, whatever that was, nums, let's say if nums of I is less than equal to target, if nums of I is less than equal to target, that then only we'll be able to do the recursion. Otherwise there is no point. If the nums itself is greater than the target, so we can't take that particular element as our candidate. So if it is lesser than equal to, so we can just move forward with the recursion by staying on the same element or moving forward with the next element. So let's say we take that particular element first, so we will add that particular element in the combination. So combination dot push back that nums of I. So Mohit, Aman, how was the recruiting, hiring or Capgemini? Okay. So combination dot pushback nums of I, and after then we can just do the solve recursively. So I will be +1, let's say, or rather let's say we will be just staying on the same index for now, and we'll be doing target minus nums of I. But after this recursion gets over, we need to also take care of the condition that we move on to the next element, or the same element condition we have already taken. But what if we move on to the next element? So for the next element, what we can do, we need to first remove this particular element. So if we remove this particular element, what we'll be doing, a combination dot pop back, combination dot pop back. And after that we do not need the if condition, because we are just moving forward with the next element. So anyways this condition will be fulfilled in the next iteration. So after this if condition ends, we'll be writing again this we'll be doing the recursive call again by I +1, and target will remain as it is because we haven't taken that element, we have just moved forward with the next element. So we can just return after that. So yeah, this is how it will be followed. So Aman, Mohit, just focus on easy medium DSA. Yeah. So let me just check the stream as well from my phone. And after this we'll be just writing the code in the editor. So yeah, we can just write the code now. I also in 7th. So yeah, first we'll be creating the resultant vector of int result, and we'll be taking the combination as well, vector of int, let's say combination that we have till now. Then we'll be calling a recursive function that will be gathering all of the valid combinations, and after that recursive call we'll be just returning the result. So in that solve function we'll be taking the candidates, we'll be taking the target, we'll be taking this particular result, we'll be taking this particular combination, and we'll be taking an index which will denote what index we are currently at, what number we need to currently take. This push and pop back step is take or not take in situation, right? Yeah, this is the same thing. If we are doing push, that means we are taking that element, and if we are doing pop back, that means we need to try out the other scenario. So if we are trying out the other scenario of not taking that element, so obviously by the first recursion call we have already taken that element, so now we need to remove that element and then move forward with the next recursion call by not taking that element. So that is what that means. Yeah, you are correct. So yes, we'll be taking that. Now we can just write the recursive function, which it will be void. We'll be taking vector of int. Let's say we take it as we name it candidates only, right? Yeah, we can name it at candidates. We take target int target, then vector was vector, oh sorry, it was just vector of int, not vector of vector. And now vector of int result and vector of int combination, and in the end we can just take the I as the index. So now we'll be writing the base case. If I equal to candidates dot size, that means if I equal to n, then we need to check whether our target has become 0 or not. So if our target has become 0, that means the current combination is valid, so just push it into our result. So result dot push back combination. Now if after that if the target is not equal to 0, we just need to return. And even though if target is 0, we have pushed it, now we don't need to do further recursion call, so just simply return from here. Otherwise we have the choice to take that element, and we'll be taking that element if and only if the target or the, like, let's say candidates, the current number is less than or equal to target. Because if it is greater than target, that means it is no point on taking that element, because then target will become negative. So if candidates of I is less than equal to target, then only we'll be taking that. So how do we take that? We just push it into our combination. So combination dot push back what? Candidates of I, and then we will do the recursion call. So recursion call can have multiple scenario. Either we can be at the same element or we can be at the next element. So let's say we are at the same element, so we'll call the solve function by like something like this. Everything will remain as it is, like candidates will remain same. This target will get changed. Target will be target minus this candidates of I. Then result will be there, combination will be there, and I will be same, because we are just staying at the same thing. But we can have also scenario of not taking that element and staying at the same index, staying on to the next index as well. So what we can do, we can just pop back thing. We can just remove the last element that we have from the combination. So combination dot pop back, and after that we can just call that recursive function that will be taking to the next recursive step by I plus 1. So I will written a typing mistake here, result. So I can just take all of this and just paste it here, and here it will be I plus 1, and here it will be remaining target only. So yeah, after that we can return or not return, doesn't matter. So let us see if this works fine or not. So yeah, it works on example test case. Let's see if it gets accepted or not. So yeah, it got accepted. So let us see in the chat if you have any doubts. Yes, no, it is not necessary that for not taking only we are taking the we are calling the index plus 1, because we can have scenario like we have taken the element and still we need to go I plus 1. So you can see this case, we have taken this element, and in this case we have just remained to the same element. But what if we need to take this element and still we need to like what you can say, move on to the next index? So for that case we have already taken that element, and now we'll be moving forward with the next element. So both the case follows, because we have seen in the drawing example as well, right? So let me show you here. It will be easier to understand with the help of the drawing explanation. So where was that? Yeah, here we are taking this particular 2. So now we had two choices. Either we can stay at 2 and take that element. So we stayed at 2 and we have taken that element. We can we can not take that 2 which I have not drawn here, but we can take 2 and move on to the next index. So we take 2 and we moved on to the next index, and we have taken that index as well. So I Infosys. Aman is asking why we wrote the solve function outside the bracket. You are talking about this last one. Okay, you got it. Yeah. So if you have any doubts, I can explain it again, but you are saying you got it. Yeah, that is good. If you try to understand with the drawing explanation, it will be very easy rather than just thinking in terms of code. First, understand in terms of by drawing the recursive tree. After you draw the recursive tree, this code will be automatically like natural to you. Yeah. Okay. So we can just take a break of let's say 10 to 15 minutes, and we can continue with the next problem. Next problem will be combination sum 2, and after that in the end we'll be taking the trapping rainwater problem, and then we can just chat like for like half an hour or so, and yeah, that will be the plan. So if you want to discuss anything, we can discuss, or we can just move forward after 15 minutes or so, 10 to 15 minutes. Should we discuss combination sum 2, or we can just directly move on to the hard problem, because combination 2s is not very difficult from this, like it is almost same logic, so I don't think there is any point in doing this combination sum 2. If you want, I can discuss, but it is exactly similar problem with only one constraint, that you cannot use one particular element like any number of time, unlimited number of time. You can choose one element only one number of time. So it is not that much different, but if you want, we can discuss, or if you don't want, we can just move on to the hard problem for the day. That is the trapping rainwater problem. So whatever you say, we'll be doing that. If you want combination sum 2, I can explain that, or if you don't want that, we can just move forward with the trapping rainwater also. That is the hard problem for today. So probably just some change, yeah, like just change in the condition, and we need to just sort, because there is one additional condition that the solution must not contain the duplicate elements. So based on that, we'll be uh, like sorting initially, and we'll be just comparing whether due to sorting all the repeated elements will be in front of us. So we'll be just checking whether the current element and previous element are there or not. So instead of like directly checking the if else, the block that you have written will be using a for loop for that. uh, that is it, rather than everything else is same. The logic is completely same, just the code, the way of writing code will change due to the duplicate condition and one element at a time condition. So yeah, hard problem, let's do it. Yeah, so we can just move on to the trapping rainwater part then. So yeah, trapping rainwater problem. So let us read the problem first. So you are given n non-negative integers representing an elevation map where the width of each bar is 1. So you are given an elevation map. So here width means this particular block from 0 up till this black block. So each has the width 1. So its unit value will be 1 only. So now we need to compute how much water it can trap after raining. So you can understand this in particular way that like these are the buildings, and within those buildings, like the area between them, the empty spaces between them, if rain comes, how many water it can trap. So in this first example, the problem statement is pretty much straightforward. uh, let us see this example. So in this case you can see there is nothing to the left, so even if we just like add some water here, it will just overflow to the side, so it can't trap any water. So we'll be moving to here. So if we are at this particular stage, there is nothing to the left, so and nothing supportive to the right. So if we place, like if the rain comes, so the water will just move towards the left side and it can't trap any water. Now when we are at here at this particular position, the left part has the boundary of 1 unit and the right part is having the boundary of 2 unit. So it can trap water with 1 unit. Why 1 unit? Because if you try to put more water here, it will overflow, because the left part doesn't have the height of 2. So left part has height of 1 and the right part has the height of 2. So if more water comes, it will just flow from here, it can't get up to 2 height. So this is what the idea is behind this particular problem. And there is one more thing that we need to notice, and that is this case. So in this case you can see the left height is also 2 and the right height is also 2, but still it can store only one volume of water. Why? Because the height for this particular building is itself 1 unit. So whatever the volume that we have, we need to subtract it with the current height. So initially what would happen if this building was not there, this particular height was not there, the left has the 2 unit height and the right is also having the 2 unit height. So it can trap how many units of water? 2 units of water, because minimum we need to take. So minimum of 2 comma 2 will be 2 only. So it can trap 2 amount of water. But this building has height of 1 unit, so we need to subtract that 1 unit, because in that part we can't trap any water. So from 2 volumes of water we will be subtracting 1 volume of water, so it will be nothing but 1 volume that we can trap. So that's why here it is 1 volume. So in the end we just need to accumulate all the volumes and return the answer. Can we apply stack? With stack, I haven't tried with stack. We can use 2 pointers, we can use a brute force, and we can use no, stack will not be applicable in this case. No, stack will not be applicable. How can we use stack in this case? No, I don't think stack can be used in this particular case. We can use 2 pointers technique. With the help of 2 pointers we can like use the prefix sums and suffix sum techniques, and we can use the normal brute force approach. So we'll be seeing the brute force approach, we'll be seeing the prefix suffix technique, we'll be coding the prefix suffix technique, and we'll be discussing the 2 pointer approach. 2 pointer code will not write, and there is just a slight change, so that's why we'll be discussing in detail, but just a slight change. Questions like this really confuse me. What data structures to use? This is completely normal, Aman, but it with time you will be able to understand, to find the observations and all of that. Finding the next greater and next smaller element. In this case, how we can apply the next greater element? In this case, it won't be exactly like next greater you can find, like, okay, in the right side what is the next greater element, but for the uh, we don't actually need to find the next greater element. We can find the smaller element towards the right, and actually you can use a monotonic stack. Yeah, maybe it could happen like with the stack as well, but yeah, there is efficient and easy way for solving this, using two pointer and prefix sum. Maybe let's see if there are solutions related to stack. I don't think like stack can happen. Let's see if stack is possible. Yeah, it is saying stack is possible, but I haven't seen any solution with stack. Let's see if we can find some. Let's do two pointer. Yeah, we'll be discussing brute force, we'll be discussing prefix suffix technique, and we'll be discussing the two pointers. We'll be discussing all three step by step. Yeah, it is possible, but yeah, uh, we can do it with like, anyway, doesn't matter. So let us understand this particular problem. So in the end we just need to like accumulate all the volumes of water, and we need to return that. So here 1 unit of water is stored. Here 1 2 3 and 4. So 4 plus 1 5, and 5 plus 1 6. So in total we can trap 6 units of water, or 6 volume of water. So that's why you can see the output is 6. So let us take this particular example and try to think in terms of brute force approach. So what will be the brute force approach? So one thing is for sure, right? If you are at particular point, let's say if you are at this particular position in the middle one, so in order to trap water you must have some support towards the left, and you must have some support towards the right. Support, I means you must have some obstacle. That's when you will be able to trap water, right? So at each and every point you need to find what is the left side obstacle that we have. Obstacle means the building or the height that we have. So what is the height that we have towards the left, and what is the height that we have towards the right? And in order to store the water, we will be trying to find the maximum height that we can get, because the minimum ones will be already like over covered by the maximum height ones. So in this case you can see, even though we have one height of 1 unit, we can still see that there is a height of 3 unit. So we can go up till 2 units with the height 3 as well, because here we have 3 and here we have 2. So even though there is 1 unit height in between, we can still fill up to more than that height, because towards the right there is more height which is greater than this particular height. So that's why we can always try to find the maximum height towards the right and maximum height towards the left. So I hope you get this point. This is little bit confusing, just to make you understand like this. But yeah, like what how can I explain in more better way? Yeah, like, if you want to store water in this particular area, so you must have some support towards the left, and you must have some support towards the right. Now even though in the right part or the left part, we will be always trying to find the maximum support that we can get in order to store the water. So let's say in the extreme right we have the highest height. Let's say in the extreme right we have the highest height, and the in the extreme left we have the highest height. And let's assume, let me just draw it in the Excali draw, it will be more suitable. So So let us assume some scenario. Let's say this is the case. This is the extreme height that we have towards the left, and this is the extreme height, extreme right height that we have towards the right side. Now in between there may be something, there may be something, but you tell me, in order to trap water, do these things matter? Do these things matter? No, because we already have support at the maximum at the top. Yeah, these things will matter for that particular position when we need to subtract this height. But in order to contain the most amount of water, in order to contain the water at most, we only care about the maximum heights, because that's when the minimum will be overcovered by the maximum height. So you can see, even if there is the height here also, so let's say we trap the water here, we trap the water. So does this water will be trapped till here only? No, because rain is coming continuously, so it will overflow, it will go till here. Rain is coming continuously, so it will overflow here also, it will cover. So will it just stop till this unit of height 1? No, because now there is no height to obstruct rather than this extreme heights. So if the rain comes, it will just completely cover this entire thing. So that's why we only care about the maximum height ones. So at any particular point, we just care about what is the maximum height towards the left and what is the maximum height towards the right for any given particular position. Now let's say we have the maximum height and the minimum height. So let me just draw another scenario. So let's say we have, let me change the color. So let's say we have maximum height on the left as this, and we have the maximum height on the right as this. Now let's say this is 3 units. Let's say this is 3 units, and this is, let's say, 2 units. Now when the rain comes, will it cover entire 3 unit? Will it cover entire 3 unit? When the rain comes, will it cover this entire 3 unit or not? No, it will not cover, because if rain comes till here, now after that this will overflow from here. So we can't go above this 2 height. So what we can do? We'll be having the left max with us, we'll be having right max with us, right? We'll be having the left max with us and we'll be having the right max with us. So we need to take minimum of that. We need to take minimum of the left max and minimum of the right max. So this is one scenario. So let us understand another scenario with the same kind of example, but we will just modify the equation that we have till now. So let's say we have the left max as this and we have the right max as this. This is 2 and this is, let's say, 3, and now we have this particular height of 1 unit. So this is 1. So at this particular point, how much amount of water that you can store? Let us just think about that. Don't think about this much area, don't think about this left area or right area, just think in this particular part. How much water you can trap at this particular width that we are pointing currently. So you will again find the left max, you will again find the right max. So left max that you will have is 3 and right max that you will be having is 2. So left max is 3 and right max is 2. Now what will be the amount of water that will be stored? Minimum of left max and right max. So what will be the minimum of this? Minimum will be 2. But can we actually store 2 units of water here? Can we store 2 units of water here? Can we store this entirely? No, we cannot store this entirely, because this building will not be holding the water. This building is an obstruction here, this building is an obstacle here, so this will not hold the water. So what we need to do, we need to reduce the height of I as well when we are at whatever position we are currently at. So what will our final equation would look like? So our final equation will look something like this. So left max comma right max, so minimum of that and minus the height of I, minus height of I. Yes, so this is the equation for the current width, how much water this current width, the current position can hold. So this is nothing but how much water the current width can hold. So this is the equation, and we this thing will be doing for each and every width. So what do I mean by each and every width? So if you look at this example, so this is one particular width, right? This is one particular width. Then this second block, this is one particular width. So this is one particular width. So there are total how many widths? These many number of widths. So for each and every position we'll be doing the same thing. We'll be using the same equation. But how do we do it? How do we find this left max and right max? So now comes the brute force approach. So there is one possible way that where is the diagram? Let me just take this particular diagram. So in this diagram, what you can see, what we can do, at each and every position, when we are standing at this particular position, we can iterate again from the left to find the left max till now, and we can iterate again from the right to find the right max till now. So for each and every position we'll be finding the left max and we'll be finding the right max. So how the equation would look something like this, not equation, like the code. So we'll be doing it for each and every I. So for I equal to 0 up till I is less than n and I plus plus. So for each and every position we'll be finding left max and we'll be finding right max. Now in finding the left max and finding the right max, we'll again need a for loop. So what this will look, so we'll again need a for loop up till the current index. So let's say we are going from j, and for the left max we'll go from j up till j is less than I and j plus plus. So this will again take a loop, and for the right max, how it will look like. So let me show you. For right max we'll be iterating from the end. So for j it will go from n minus 1 and j will go up till j is greater than equal to I and j minus minus. So you see we have one outer loop for I which is going from 0 up till n, and we have internal loop for left max and right max. So how can I write this? Yeah, so we have this left max function, let's say it will find us the maximum left till now, and we have the right max function which will give us the maximum height that we have towards the right. So these will also contain the for loops, and in worst case they can also go up till n length. They can also go up till n length. And rest everything remains same. Once we find the left max and right max, the code after that remains entirely same. That will not change. The main important thing is that this time complexity will become how much? This O of n, and these can also in the worst case can go up till n length. So this will also become O of n. So for each and every index from 0 to n, we are running n number of time. So for 0th index we are running O of n, for 1 index we are running O of n, for second index we are running O of n, up till nth index or n minus 1th index we are running O of n. So in total n times we are running O of n. So what will your time complexity will become? Your time complexity will become O of n square, just to calculate this entire thing, left max, right max for each and every index. भैया मैंने AIML लिया है तो क्या कोई दिक्कत है इस कोर्स में? I do not have much knowledge on AIML. I am working as a full stack developer in MERN-Stack, so I do not have much idea on AIML. So sorry for that. I can't comment anything on that. So you see, in the brute force manner, just to find the left max and the right max, we are getting up to O of n square, and this is not acceptable. So what we can do? So whenever you can see there is one kind of pattern. First of all, before moving on to the better approach, there is one kind of pattern you can see. For each and everything we are doing the same thing again and again. So this is the repetitive task. So whenever there is a repetitive task, we always think of pre-computation. Whenever there is repetitive task, think of pre-computation. So we will try to pre-compute left max and right max. So pre-compute left max and right max. So if you pre-compute the left max and right max, so here when you come, so for this particular thing, you do not need to take O of n time to get the left max, right max. Now you can do it in O of 1 because you have already pre-computed this before. So this is how we will optimize this approach. So this is the approach of prefix and suffix technique. Actually you can use monotonic. Yeah, we can use monotonic stack as well. So finding NG and SG technique. Yeah, we can use monotonic stack as well, and let's do 2-pointer. Yeah, so we can do the 2-pointer, but before that we can just write the code for this better part, and then we can understand the 2-pointer, because then it will be much more better way. Or shall I dry run with this first example for this pre-computation technique, and then we can move forward? We can just take a simple dry run for this first example for the left max and right max, and then we'll code this prefix suffix technique, and then we'll be moving forward with the 2-pointer approach. Yeah, dry run. Yeah, that's what I am saying. Yeah, dry run. Okay. So let us take this particular case. Height array is given to us. So this is I'll not write the entire height. Let us assume that this is the height array given to us. What was that? 0 1 0 2 1 0 1 3 2 1 2. In the end we have 1. Yeah, so this is the heights array. So first of all we need to compute the left max. So let's write it. This is left max, and we'll compute right max. So these will be also of the same length. Right max and left max will also be of the same length, that is n length. So initially they all will be containing 0 values. We will initialize each and every one with the 0. Now when we are at here, this first index, we will say, okay, what is the left max till now? What is the left max? So initialize with everything with 0. We will have the we can take one variable also. let's say lm left the array name is we can name this array as left, and we can name this array as right actually, otherwise it will get confusing. And we can take two variable, left max lml maximum left and mr maximum right. So these will be the variable that will be containing the maximum left till now and maximum right till now. So for the maximum left till now we will be initializing it 0, and maximum right till now will be initializing with again with 0. So when we are at index 0, we will say okay, what is the maximum left that you have till now for this 0th index. So for this 0 index, the left will be the values before that will not include this particular value. For left we will try to look before that. So before that everything is 0, so we'll make sure that here it will be 0. Then we will also check okay whether this particular value is greater than this current ml or not, because this will affect our future answer. So let's say when we will be at 1, so this 0 will be now left of this 1, so we need to update our ml as well. So I hope you understand what I'm saying. Even if you don't understand, in the dry run you will be able to understand easily. So whether this ml, this 0 is greater than this current value 0 or not. No, it is not greater, so it will be 0 only. So now we move on to this first index. So for first index we'll find out what is the maximum left that I have towards my left. So our maximum left is 0, so here also we'll be putting 0 only. So here we'll be putting 0 only. Now we need to also update. Now this 1 will become left of this 0, so we need to update our maximum left if this 1 is greater than our current maximum left. So if you see, our current maximum left is 0 and our current value is 1. So you see 1 is greater than our current maximum left, so we'll update our current maximum with 1. And now we'll be moving forward, and now we are at 0. Now we are at this particular 0, we will ask what is the maximum left value that you have till now. So maximum left value that I have till now is 1. So you will say okay, so for me the maximum left value I have is 1. But before moving forward, we will update our maximum left if possible. So I am 0, so is my maximum left lesser than 0? No, my maximum left is 1, which is greater than 0. So just simply move forward. So now we'll be moving forward and we will be at 2. Now 2 will ask okay, what is the maximum left value that I have till now? The maximum left value that I have till now is 1. So okay, I'll put 1 here. Now I'll move forward, but before moving forward, this 2 will now become the left value for the further elements. So we need to update our maximum left. So we'll check whether our current maximum left is greater than this 2. No, it is not greater than this 2. That means we found a new maximum left value. So we'll update this 1 to 2. And then now we'll be moving forward. Now we'll be at 1. So at 1, it will ask what is the maximum value that we have towards the left. So the maximum value that we have towards this left is 2. So we'll write here 2. And this will not update because 2 is greater than 1. So ML will not update. Now we'll be at 0. It will again ask what is the maximum left value that we have till now. It will say 2. So here also we'll be having 2. So I'm just skipping forward for quickly, because here all the values will be same. And so maximum value will also not update here. We'll be moving forward with that. 1 will ask what is the maximum left value. It will say 2. It will again not update because 1 is lesser than 2. So now he will be at here 3. So 3 will ask what is the maximum value that I have till now on the left. So it will say 2. So okay, 2 is now. Now before moving forward, I have the greater height than your current maximum left. So I might be greater for the next part. So this maximum left will now update to 3, because for the future elements this will be the maximum height towards the left. So if 2 will be here, 2 will be looking towards the left, he will be looking at the maximum left as 3. So that's why we need to also update this maximum left if we found any new greater element. So yeah, in this way your next greater element, next smaller element concept will work. So yeah, you were right, Aryan and Dhruv. We can use NG, SG as well. So yeah, now we are at this particular 2. So 2 will ask what is the maximum left that we have. It is 3, so we'll just move forward. This will also have 3. this will also have 3, and this will also have 3. So this is how our maximum left will look. Now for the right part. So for the right part, we'll be starting our iteration from the end, because obviously we need to search towards the right. So to search towards the right, we need to start iteration from the back. So that is what we'll be doing. So initially everything will be initialized with 0. So our current maximum right will be 0. This one, can I just erase this above thing? If yeah, it will be much easier then, otherwise it will be very confusing. Yeah, it looks cleaner now. Yeah, so we are at this particular position. This element will ask what is the maximum right towards me. So the maximum right towards me is 0, so we will update this particular thing with 0. Now before moving forward, just update, because my height is greater than 0. So for the further elements that will come, they should look me as their maximum right. So we'll just update this maximum right, because this 0 is lesser than 1. So now 1 will be the next maximum right for the upcoming elements. So when we now come at 2, 2 will ask what is the maximum right for me. It is 1, so we'll update it with 1. And before moving forward, this 2 is again greater than 1, so we'll update this maximum right with 2. So now when we are at here 1 will ask what is the maximum right. Maximum right is 2, so we'll update it by 2. And this is not greater than 2, so we'll not update our maximum right. Now when we are at here, it is 2. The 2 will ask what is the maximum right. It is 2, so we have already written 2. And yeah, this 2 is not greater than 2, so we'll not update it. Now we are coming at 3. So 3 will ask what is the maximum right that I have. So it is 2. But before moving forward, just update it, because 2 is lesser than 3. So your maximum right will now become 3. So now when we'll be coming at this particular 1 will ask what is the maximum right that I have. So maximum right is 3. So we'll update it with 3. So now we'll be moving forward. All will store the same value. So we can just write 3 for this particular 0. Then 3 for this particular 1. Then we can have 3 for this particular 2. Then we can have 3 for this particular 0. Then for this 3 for this particular 1, and this 3 for this particular 0. Now we have our maximum, we have our left array and we have the right array. Now we just need to find the overall unit of water that we can contain. So let me just write this entire left array and right array in a cleaner way for the further dry run, because it will be much more easier then. Let me just erase this unnecessary part for now. So I hope you all are understanding. If you did not understand, please let me know. I'll be happy to explain this entire thing again. I have no problem with that. So yeah, let me just copy this thing. Yeah, so I'm just rewriting this left and right array. So it is 0 0 1 1 2 2 2 2 3 3 3 3. Yeah, so let me just draw a line so that we do not confuse. And here we have 1 2 3 4 5 6 7 3. Okay, 3 2 3 4 5 6 7. Sir, you are very good teacher. You have so much patience. Salute you. Thank you, Dhruv. This really means a lot. Thank you so much. This really motivates me to keep going what I'm doing. Thank you so much. Really means a lot. So then we have 2 2 2 1 0. So this is the left array and the right array. So left and right. Now we need to calculate the volume, but for that we also need to take care of the heights, because we have already seen if we have a particular height at some position, we need to subtract that particular volume from that height. So we need to take care of the height array also. So we just write the height array again also, and then we will do the calculation part. So what is the height? 0 1 0 2 1 0, 0 1 0 2 1 0, then 1 3 2 1 2 1, 1 3 2 1 2 1. Okay, 1 3 1. Yeah, so now we just need to follow the equation for getting us the correct answer. What equation? The equation that we discussed earlier, this particular equation. This is everything for this particular problem. Now for each and every index we just need to calculate this and add this, whatever this gives us the answer, just add it to your overall result. This is the main thing. Now it will be just very easy to understand everything. So we will be first iterating for this index one. So let me choose a different color pen. So we are at this particular index. So this particular index, what will be, let me just write the equation also. So minimum of left of I, comma, right of I minus height of I. Yes. So for this particular height, what is the left of I? Left of I is 0. So okay, 0. What is right of I? Right of I is 3. Okay, we need to take minimum of that, and minus height of I. Height of I is what? Are we doing anything wrong? No. Yes, everything is fine. Yeah. So height of I is 0. So we need to subtract 0. So minimum of 3 comma 0 is 0. 0 minus 0 is what happened with my pen? Yeah. Minimum 0 minus 0 is 0. So till now our volume is 0. Total answer is 0. So we will be keep adding this to our answer as well. So till now, up till this point, our answer is 0. So now we'll be moving forward with this particular index. So now we are at this index. So at this index, left of I is what? So I'm just writing the main values here. Yeah. Now, so left of I is what? Left of I is 0. Right of I is 3 minus height of I. So height of I is what? Height of I is 1. So minimum of 0 comma 3 will be 0. 0 minus 1 is minus 1. But we will not add this to our answer because negative is nothing. So we'll be keeping track of that particular condition. If the answer is positive, then only we'll be adding that answer. Otherwise we'll not add it to our answer because like negative water is nothing. It doesn't make any sense. So till now we have 0 water, and if you look at this particular graph, till this point we have 0 water only. So till now we are doing everything correctly, and hope we will be doing till the end also, if there is no mistake till now. So I'll just erase these examples, and we can take for the next iteration. Yes. So now we'll be at this particular index number 2. So for this, left of I will be 1. So we'll be taking minimum of 1, and right of I will be what? 3 minus height of I. Height of I is 0. So 1 will be the minimum minus 0, that is 1. So we'll now update our answer with 1, and if you look at this particular graph, you can see 1 unit of water is there. So till now everything is fine. Now we'll be at this particular index. This has 1, 3 and 2. So minimum of 1 comma 3 will be 1 minus this particular height. Height is 2. So 1 minus 2 will be minus 1. So this doesn't make any sense. So we'll not add it to our answer. So you see, for this particular height we did not add anything. We did not contain any water. So till now everything is correct. Now we can move forward with this particular index. So minimum of 2 comma 3 is 2. 2 minus height is 1. 2 minus 1 is 1. So we'll add 1 to our answer. So our answer will now become 2. And if you look at this particular thing, we have 1 unit of stored water here. Now we'll be moving forward with this particular index. So let me erase this part. So I'll be taking a little bit time because I just need to erase this thing and all of that, so it might take a little bit time consuming. So yeah, now we are at here. So here it is 2 comma 3, again 2 comma 3 and 0, or did we do this thing already or not? Did we do this? Yeah, we already did this. So we already did for this particular thing. We need to go for this particular index 2 comma, yes. So now we are at this particular index. We need to take minimum of 2 comma 3. Minimum of 2 comma 3 is 2, and 2 minus 1, it is 1. Yeah, 2 minus 1 is 1. 0 1 2 3 4 5 6. 0 1 2 3 4 5 6. So yeah, at this 6 index we have 1 unit of water. So we add plus 1 to it, so our answer will become 3. Oh sorry, we haven't calculated this particular answer. I am sorry for that. So we can just do it. For this index we did not actually calculated the answer. So minimum of 2 comma 3 is 2. 2 minus 0 is 2. So we just add 2 to our answer. So answer till now will be 5. So till this point 5 unit of water is stored. So if you see till this point, till 0 1 2 3 4 5 6, till this 6 index we have 5 units of water stored. So let's compare till this 5 index 0 1 2 3 4 5 6, it was 6, right? 0 1 2 3 4 5 6, yeah, till 6. So till 6 whether we have 5 units of water or not. So there is 1 1 plus 2 3, 3 plus 1 4, 4 plus 1 5. Yeah, so we are doing everything correctly till now. Now we came across this particular index. So now here minimum of 2 comma 2 will be 2. 2 minus 3 will be minus 1. We don't take care of this particular thing, we just now move forward. Here we have 3 comma 2. So minimum of 3 comma 2 is 2. 2 minus 2 is 0. So we don't add anything. We now move forward. We have 3 comma 2. So 3 comma 2, minimum of 3 comma 2 is 2. 2 minus 1 is 1. So yeah, we add 1 to our answer. So answer till now will be 6. Then we have 3 comma 1 comma 2. So minimum of 3 comma 1 is 3, minus 2 it becomes negative, so we don't count it into our answer. So till where we have done 3 1, yeah. So again it is same, 3 comma 1 it will be 1, minus 3 comma 1 will be 1, and if we subtract 2 it will be, yeah, the same thing. We have already did this, and in the end we have 3 0 1, it will be again negative, so we don't add it to our answer because minimum of 3 comma 0 will be 0. 0 minus 1 is again less than 0, negative, so we do not add it into our answer. So our final answer or the final volume of water that we can contain is 6. So if we look at this answer, so yeah, it matches our answer. So the entire process, the entire dry run, if we that we did till now, is entirely correct, and thankfully we didn't do any mistake, otherwise all of this thing would just go in vain, and instead of understanding we would have just been more confused. So yeah, till now if you have any doubts, you can ask me whether this dry run, you understand this dry run or not, whether I made it more confusing or whatever it is, you can just ask me or tell me, and after this thing we will just write this write code for this. You make it. Thank you, Dhruv. Thank you so much. Thank you so much. So yeah, we'll now be just writing the code. Let me check the live stream, how much delay it has. You make it. Thank you, Dhruv. Thank you so much. Yeah, there is not much delay. So yeah, we can just write the code now. I hope everything is clear to you till now. So yeah, what we need to do, first of all, we will take n as the what you can say, integers, height array size. So int n equal to height dot size. After that, what we will do, we will take two arrays, left and right. Those will take the left max and right max. So instead of that, we can just write left max vector of int, or rather just name it left, because in the drawing explanation also we have named the left, so that we do not confuse. We will take a right vector of int right. It will be n comma 0. Everything will be initialized to 0. Now we will pre-compute this left max values and right max values, and initially we will make this ml equal to 0, which is the maximum that we have till now, and maximum right that we have till now. Both will be initialized to 0. Now first of all, just pre-compute the left part. So for int I equal to 0 up till I is less than n, I plus plus. So now at this position, what we will ask at this particular index I, what is my maximum value towards the left, that we will be storing in our left array. So left array will be storing the whatever the maximum value in the left that we have till now. And what is that value? That value is ml. Now what we have seen, if this particular height is greater than our current ml, then we need to update our ml as well, right? So before moving forward, because this particular height in future might be like left max for some other value, right? So before moving forward, just check whether this current height of I is greater than ml. If it is greater than ml, that means we need to update this maximum left. So we will update our maximum left with height of I, and then it will keep on going for each and every index. So if you just want to check, we can just print out this entire thing, and we can check the array that we created. It will be same only. For now we can just return 0, and let's check whether we build this particular left array correct or not. So you see we have 0 0 1 1 4 2 and 4 3. So let us check. So 0 0 1 1 4 2 and 4 3. Yeah, so our left array has become exactly correctly. So till now we are going correct. So now we need to build the right array. So to build the right array, we need to start from the right side. So we'll be starting from the end. So for int I equal to n minus 1 up till I is greater than equal to 0, I minus minus, we'll do the same thing. This particular index will ask what is the maximum right value that I have till now. So that we need to store. So for right of I, we will be storing mr value, that is nothing but the maximum right value that I have till now. Now before moving forward, if this current height value is greater than the maximum right value that we have till now, we need to update that. So if HEIGST of I, height, is greater than mr, we just need to update it. Update what? Update this mr. Mr will be nothing but height of I. And yeah, we can do the same thing again. We can just print out this right value also here, right of I. And before that, we can just do a cout, leave a line. Yeah, oh okay, so we remove that return. So you see 0, we have how many 3? 3, 1, 2, 3, 4, 5, 6, 7, 3, 3 2 and 1 0. So 1 2 3 4 5 6 7 3 3 2 and 1 0. So yeah, our left and right both are correct till now. Now after that, what we need to do, we just need to do the simple calculation of finding the volume. So our total volume will be stored in our answer, and we just need to now iterate over each and every particular value to find how much this particular unit will contain water for this particular place. So for that we need to find the current volume. So current volume will be nothing but minimum of left of I, comma, right of I, minus height of I. And we need to check whether this volume is greater than 0, then only we will add it to our answer. Otherwise we won't add it, because we have seen it can go to negative, and negative means that just that there is a very tall building and volume can't be contained over that. So if volume is greater than 0, then only add it to your answer. So answer plus equal to volume, and in the end we will be just returning that particular answer. So minimum of height, yeah, I think it is correct, and we have removed every return. Yeah, so just submit this, hopefully it runs fine. So yeah, you see it run fine on the example test cases. Let us submit this and hopefully it gets submitted. So yeah, it got accepted. So yeah, if you have any doubt you can ask it, and then we will just discuss the 2-pointer thing. We'll be not going into that like very detailed that we have done till now. It is a very basic idea. Instead of that, we can just do with this 2-pointer. Actually we already using this 2-pointer. Sir, how you figure out that we need to find only that how much water the current bar can hold instead of finding the water between the multiple bar? Because if you look at if you look at this particular diagram, you can get intuitions by trying out on the example test case. Because if you look at this particular case, then you will think, okay, we need to find between the buildings. But if you look at this particular case in which this particular unit of water is there, so you get the idea that okay, we need to do this width wise. 1 unit of width, what is the right maximum, what is the left maximum, not like that how much in between is there and all of that, because that will be already contained when we have a particular height. So you see, if we have a height, still we'll be calculating the same with the same formula. But if we do not have height, then we will not think okay, we will be calculating this part and this part. No, we just care about this part. We need to do it individually, then only we'll be able to do it. So if you are asking how did I figure out, I just look at the example, and at this particular case I genuinely got confused when I did it for the first time, when I like 3 to 4 years back. But when you look at these cases, these particular test cases, this particular use case, you see you need to do it unit wise. And if you find anywhere in the example that okay, we need to this is the smallest part, this is the smallest thing that we need to compute. So in this case, you see we need to find out for this particular unit only, because you cannot control the right parts and the left part. So by looking at the example, like this is the best I can explain, like by looking at the example I was able to figure it out when I did it for the first time. And also if you look at this particular problem, they have said that the width will be of each bar 1. So if there is a specific condition given that there will be a width of 1 only and all of that thing, so always try to think in like unit wise. And what is the unit here is width 1. So you try to compute width wise, with width being 1 unit. So if there is some special conditions given, so you just keep those things in your mind, so that it will be helpful in solving problems. So I hope like this makes sense. This is pretty much confusing like what I just said, but like yeah, this is how I figured it out. It is not a straightforward thing, it was just a trial and error by a lot of times and getting out to the conclusion. And the conclusion was that if problem statement has mentioned that width you need to take as minimum, minimum to be 1, so we just need to think in width 1 only. Okay, okay, welcome Dhruv. I hope you understand. So yeah, we can just we can just discuss the two pointer approach. If you do not have any doubts, we can just discuss. We'll not be writing the entire code, and will not do the entire dry run explanation. We can just understand with the help of this case only. Yeah, so the two pointer is pretty much straightforward and simple. Actually, we'll not be writing the code. We'll be just getting the idea how it works and why it works, because if we do that, it will again take like around 30-40 minutes or so. So there is no point. It is pretty much straightforward. Removing few lines of code will also make it possible to execute it. So what the two pointer approach will be. Now how do we get the idea that we need to apply this two pointer approach? It is running fine, it is coming in the expected time complexity. So how do you get the idea? So when you look at this particular thing you write there, we always want to take minimum of right or left, right? We always take either minimum, whatever is the minimum, either left part is minimum or right part is minimum. So you observe one thing, we don't care about the maximum value, we only care about the minimum values. So the idea of the two pointer approach will be, whether we are moving the left pointer or right pointer, instead of pre-computing, what we were doing in this case, in this particular iteration, the end iteration that we were doing on the heights array, we can just do everything inside this only. So initially what we can do, we can have one left pointer here and we can have the right pointer here. So we will not pre-compute this everything. Initially we will keep those variables ml and mr, obviously, which will be 0 and 0. So at these points we'll be thinking what pointer value we should move. Either we should move the left pointer value or we should move the right pointer value. So whatever will be the minimum, will be moving forward with that particular value. So if at this point the maximum left is lesser, then we will try to find out the then we will try to go out to the right part. And if the right part, like what you can say, if the right part is right max is lesser than the left max, then we'll try to go towards the left part. So here in this case you can see this 0 and this 1. So this 0 is lesser than this particular right part, so we'll be moving forward with the left part. So here you can see there is 1 and there is 1. So when there is a condition of both being equal, then you can move any pointer. So you can move either right or you can move either left. So like it is becoming very confusing for me to make it understand. How can I explain this? So let me just give you a basic idea, otherwise it will be rather more confusing. So the basic idea for this two pointer technique will be, with the explanation it will be very much confusing, so I'm just writing it in points here. Two pointer approach. So the basic idea would be, we only care about the minimum value that is either towards the left or towards the right. So if we are only cared about the minimum values, so we don't need to take care about the other maximum part, right? Because even if you have even if you have some scenario like this, let's say you have a building, let's say you have a building here. So in this case, if you are calculating for this particular part, so you only cared about the minimum because only minimum can change your answer. If you have the maximum building towards the right part, then no matter how much length, how much height building there is on the left, it doesn't matter because we'll be taking the minimum only. So until the right part is maximum, we only cared about the left part because left will be always lesser than the right. If left is always lesser than the right, then obviously we'll be taking that left height into our account. So let's say for these many places, we actually do not care about this right building because we can trap water till this part only, right? We can trap water till this part only because left already has a lesser height than right. So that is what the main idea is. Whatever is the minimum, we only take care about that part. So if we have already on the right part the very high building, and on the left part we have the low building, so we need to move left towards the right because now we need to contain more water. We need to find that whether we can contain more water. So to whether we can contain more water or not, we'll move the left pointer ahead because that is the only part that is deciding whether we can store more water or not, because right is same. Right is having the maximum part. Our volume will be decided now whether left can be increased or decreased. So what I'm saying, let's say whether we get a height to this point. So now in this part you can say okay, we'll be storing much more water. So how did we come to the conclusion that okay, we will be coming at this point and we'll be storing this much amount of water? Because here right was already at this point, so our right will be always pointing towards this. But when we were here, we saw that okay, till this part we had stored this amount of water, but our right says that right is the maximum building, so that means there can be a possibility towards going towards the right that we can fill more water if we have a higher left building. So we move towards the left. So is there anything in here? No, there is nothing here, there is no building. So then we move here. So is there any building? Yes, there is a building on the left which is greater than the previous left but still lesser than the right. So that means now our water volume will increase from this part up till the right max. So you can see from this part up till the right max our water volume will increase. So this is the basic idea of the two pointers, whether we'll be moving our left pointer ahead or whether we'll be moving our right pointer ahead. So why did we arrive at this particular conclusion? Can you explain it using dry run? Like I will be able, I'll be happy to explain that in a dry run, but it will take like around 30 to 40 minutes again. So I need to end this stream also. There is nothing much like in this. How can I explain now? Like can you tell me where did you did not understand? Because if I dry run, it is again like it is much more in terms of showing you the example with the entire step by step, it is much more longer than the prefix suffix part, because there we need to move with the pointers, so at each and every step everything gets updated at the same amount of time. No need to write new things, only explain like how pointers are. Okay, no problem. So if we take this same example, not this one, this is very complicated. Yeah, so if we take this particular example, let's say we have this particular height here, this particular height here, and let's say this particular height, and let's say some height in between. So till here, let's say we have water till here, here we have till here, till here. Yeah. Do not explain every step, only explain through by. Yeah, no problem. I'll just try to explain with my best. So let us start from here. Let us not go here, otherwise, like it will be very confusing. So let's say our left pointer is here and our right pointer is here. So you will check whether what height is higher, left height is higher or right height is higher. You check. You see, okay, right height is higher. So if right height is higher, do you think that will contribute to our answer? No, because we don't care how much high the right height is. If left is 1 unit of height, it will only contain 1 unit of height. It doesn't matter. So that is the main idea. So if right height is higher, that means we need to move the left pointer towards the right, so that we can contain most amount of water. We need to contain more amount of water. So if left height is higher, so we do left plus plus. So we, let's say, come here, let's say this is 1 unit, this is 1 unit, let's say this is 2 unit, this is 1, this is 1, this is 1, this is, let's say, 2 unit, this is 1 again. So yeah, now we come here. So now we have left here and right will remain same, right? Right will remain same, and this will happen until our left is less than equal to right. So yeah, at this particular position, our left height is 0, our right height is 0. So you again check which height is higher, right height is higher or left height is higher. If left height is higher, that means you need to move the right pointer towards the left, otherwise you need to move the left pointer towards the right. So in this, yes sir, got the point. Okay, thank you. I know, like, I couldn't explain this part in very much detail. I could do a dry run, but then it will take around like 40 to 60 minutes. This same thing entirely, but at a single step, this entire thing will happen. So that's why. This is similar to code face forces 2, 2, 3, 4. Yeah, like I haven't solved that. But yeah, like I hope you understand this prefix suffix part. That was the more important rather than this two pointer thing. If you got this two prefix suffix, then you'll be able to come up with two pointer easily. No sir, you gave your best. Thank you. Welcome. Thank you for you too. Maybe like in the next stream we can discuss this thing entirely, because there we can take 60 minutes in the beginning, and let's say in the next stream we solve one problem less, because if I explain it now, then it will be like around 2:30 or so. So can you change your like, have you yeah, you can send me your resume on LinkedIn. I haven't like opened LinkedIn today, I think. Yeah, I haven't opened it. I have opened in morning, but after that I haven't opened. So you can send me your resume on LinkedIn. I will check it. Sir, tomorrow explain today's period. Yeah, sure. Tomorrow. So let us just write what we'll be solving in tomorrow's POTD. So you have already sent. Okay, I haven't opened my LinkedIn. So yeah, I can check and review your resume. So tomorrow, what we'll be doing? So first, let's say we'll be taking today's POTD. Second, what problem we need to take second? Valid Sudoku, someone has said. Some top K also was given. Yeah, hello Yanis. Yeah, top K merged list. Yeah, top K merged list we can take. And what fourth problem we can take? Do you want to discuss this two pointer technique tomorrow in detail? I can explain with the dry run entirely. So if you want we can discuss the two pointer technique also in the tomorrow's live stream. Or we can just start with that only, the tomorrow's live stream, by starting with the two pointer technique of this trapping rainwater. If you want I can dry run it in the first 40 to 50 minutes. I'll be just dry running the two pointer technique. Yeah, no, like I'll just make a poll, so whatever gets the maximum. So yes, so you can just vote, and whatever gets the highest vote I will just do that. Or do you have any suggestion for the fourth problem, or I just take it by myself? uh, I'll just review after this stream ends. I'll just review your resume after this stream ends. Take some linked list. Okay, we'll take detect cycle or cycle in the linked list kind of something. Linked list cycle, let's say. So yeah, if you want to ask anything, you can just ask now, or we'll just end this live stream at 2 a.m. This is Python coding. No, we are doing it in C++. I currently live in Ahmedabad, but I am actually from Jodhpur, Rajasthan. Suman Dara, late night coder. This is late night algorithms. Sir, what's your opinion on current protests? Like, I don't know. I don't want to say anything on that. Sir, what's your opinion on current? Give some suggestions about CP. I am new and want to do CP. Like, I can tell you in terms of LeetCode, CP. Like, yeah, I can tell you about DSA or how to do it on LeetCode, because this is the platform that I have used the most. So just choose first language, either C++ or Java. If you are choosing C++, you can yeah, you first learn the C++ HTL. If you choose Java, you learn Java collection frameworks. After you do that, first solve easy problems, build a grip on how to uh, convert your thoughts into code, uh, do some implementation questions, simulation questions, conditional if else questions, loops question, and all of that. After that, move towards the proper data structures and algorithm questions, which is like uh, moving like pattern wise. Start with the easy again, then go for the medium, and then go for the hard ones. Yeah, and then keep on going. Like, at least try to solve 2 to 3 problems daily. Sir, are you veg or non-veg or vegan? I am vegetarian. What is the best resource for recursion? I did basically recursion from LeetCode only. I like, yeah. I just the best thing that you can understand, for the best way to learn recursion is just dry run. Just dry run, draw the entire recursive tree. With the help of recursive tree only, you will be able to make the transitions. And once you are able to make transitions, if DP problems comes, you can just write the recursion first, and just convert it into memoize DP part. That is completely simple. That is how I did. My profile review. Uh, like, have you given on my like code tips website? If you have given, yeah, I do review it. It will take like 2 to 3 days of time, because I already have a lot of profile reviews. So I just did like around 5 profile reviews today. So maybe in that yours was not there, but yeah, I'll be doing within 2 to 3 days. So as business analyst, is a Python necessary or SQL? I don't know about business analyst rules, so I can't comment anything on that. Have you tried code forces? I have done code forces in my first year of college. I have around like solved 500 problems up till 1200 rating, but then I have completely stopped that and move on to the lead code part. So we can end the poll. It is basically yes only, so I'll just explain it. So please become a vegan. It's very necessary for us. Okay, like how, hmm, how it is necessary? Can you explain? So which platform do you think is better for beginners? For beginners, I would say like LeetCode is the best platform, but I would still recommend to first go to Code Forces, have a like grind, because there you actually learn the constructive algorithms, the mathematical part, the real logical part behind it. Because even if I tell my own journey, uh, if I tell my own journey, I when I started with Code Forces, I felt like very demotivated. I wasn't able to solve more than two problems, like in the div 2 part. So uh, when I moved from Code Forces to LeetCode, the LeetCode was like very easy for me. I was able to solve like in the contest, two to three problems, three problems very often, but yeah, two problems in almost every contest without any single mistake. So like that the Code Forces grind or the Code Forces thinking, I think that made me good at LeetCode in the beginning. So leave dairy products. Yeah, okay. I'll try to do that. Like cows and buffaloes are killed. Okay. I didn't knew much about this vegan thing, so okay, I'll try to do this. Sir, did you ever tried SQL? Have you? In LeetCode, I have solved few SQL problems, but if you are saying in general, yeah, I use SQL in my like daily. Like I am a software developer working as a full stack developer, so I write SQL queries and all of that daily, in the backend and all of that. We didn't we do not write raw queries now. We use ORMs like SQLize type ORMs and all of that. But yeah, I do write, uh, I do know SQL and all of that. I do write queries. I have solved few LeetCode problems as well on SQL. Yeah, like I can just check your resume, and yeah, like after this stream ends, or maybe like tomorrow morning, I'll give you, if you do not have any problem, tomorrow by tomorrow morning, I'll just review and give it to you, if you don't mind. All right, see you tomorrow. Had a fun learning new things. Will try to join consistently. Yeah, bye Joga Banito. Bye. Good night. Okay, so yeah, thank you, Dhruv. Yeah, so within like 5 minutes we'll be ending our live stream. Do you guys use Claude or any other mainstream GPTs while working job? Yeah, like it is completely normal in job. We are allowed to use like anti-gravity, Claude and as well. Bye sir, thank you for today's session, and remember about veganism and research on this. Yeah, sure Dhruv, sure. Bye bye. Good night. Sir, if someone wants to learn Python or SQL, how do they start? SQL, like you can just start with basic select statements, and then like aggregation functions, joins and all of that. Then you can move, like first understand the basics, obviously primary key, foreign keys, associations and all of that, one to many, many to one, many to many, and all of that. And then you can just SQL is just about practice, and you can just focus on practice after that. About Python, I don't have any idea about Python because I have not learned Python. I It was in my college, so I learned as a course, but just as a basic language. I do not have very deep idea about Python. How are you doing, bro? Yeah, I am doing good. I am doing good, Abdul. How are you? How are you doing? Quite good. Yeah, that's good. Are you getting interviews? Like for quite some time, I haven't. I am not applying to any companies. So, yeah, solving all these feels kind of irrelevant if you ultimately use a GPT at last. I know this improves your understanding of the code, but still, at some point, it's like, yeah, like you can, like, it's opinion from person to person. Like, I really think that even if GPT is there, these things matter a lot, because I know when I work on projects, there are things like that can't be done by GPT until you explain the entire logic in like 3 to 4 to 5 paragraphs or so. So I, for me, like, not only logically but in job as well, this like helps, these things helps, even though GPT is still there. But yeah, because GPT is what GPT is doing is, it is already giving us the data based on the learnings it has already done. But what if uh, like but if some client comes, it has some requirements. So how, if it has some like requirements that are not general, he wants some customizations and all of that. So in order to write code from GPT, if you want that GPT should write your code, you should have a clear understanding of what the client wants, how the logic will be implemented. Because if at that point you give it to GPT, it will just give you a generalized thing. It will not give you a customized thing according to what your client needs. Even though you explain what your client needs, until you don't give the entire logic, it won't be able to generate the code that you actually want. That I am having my M3 exam tomorrow. What is M3 exam? I don't know about that. Which platform should I start with to learn SQL? Do you any YouTube videos? For SQL, you can probably use LeetCode or YouTube videos. Like SQL was in my college course, so in my college SQL was taught very like in deep manner, and it was actually two courses of SQL, so I studied both of them. So my learning of entire SQL was from my college only. I didn't learn via any YouTube tutorial or so. But for practice, you can practice on LeetCode as well. But for practice, you can practice on LeetCode as well. DSA tips, yeah, like DSA tips would be the most important tip would be to like stay consistent, solve, try to solve. If you are focusing on medium problems, try to solve 2 to 3 medium problems daily. If you are aiming for hard problems, try at least one hard problem daily. Regarding trips, like just focus on pattern, try to recognize patterns, and uh, like try to do the grind, the actual grind. Like, don't look at the solutions too soon. Try to sit for around like 40 to 50 minutes for one particular, let's say, medium problem. Try to derive all the observations. If you are solving a recursion problem, so draw the recursive tree, write down the observations that you can find. Do it with pen and paper and all of that. That will improve your problem solving ability in the DSA. So that is the tips that I can give. I am from Ahmedabad. I am currently in Ahmedabad, but I am actually from Jodhpur, Rajasthan. M3 means probability and statistics. 2 year back. Okay. So all the best for your exam, Ashir, Hadi Bashir. All the best for your exam tomorrow. Yeah. So now we can just end the live stream. So yeah, it's already 2 a.m. So yeah, let us just end the live stream, and let us meet tomorrow 11 p.m. IST. Yeah. Thank you so much for joining. Thank you. Bye bye.